Hi everyone, this is our presentation for the computer vision project, which is about top view stitching and tracking. The goal of this project is to create a top view stitch of the Sambapolis court in Trento, providing a unified perspective and then applying detection and tracking algorithms to follow players. Finally, ball tracking and color-based team identification are two additional points that will improve the analysis. For the state-of-the-art of stitching, there are different approaches that can be used for feature extraction, including SIFT and ORB. After some tests, we ended up choosing SIFT because despite it being computationally costly, it allows us to obtain a more robust feature extraction. Moreover, to improve the overall result, we follow the pipeline explained in this paper, where Ransack is used to optimize the feature matching. Then, regarding the state-of-the-art of detection, we have tried 4 different techniques, which are frame subtraction, background subtraction, adaptive background subtraction, and Gaussian average. We ended up choosing background subtraction because to the static nature of the background, since there are no light changes and it obtains a better overall performance. Finally, for the state-of-the-art of tracking, after analyzing the characteristics of these two algorithms, we choose the particle filter for its ability to handle uncertainty. For the first goal, the facility is divided into 3 views: top, center, and bottom, each captured by 4 cameras. We discarded the leftmost and rightmost views, stitching only 2 cameras per view. The stitched top, center, and bottom views were then combined together. To handle complexity, we have developed an algorithm that discards incorrect matches based on inclination, and, additionally, some features were manually hard-coded. The final result shows artifacts due to camera angles. The green circle in the left image highlights correct foot alignment, while the red circle shows misalignment in the upper body. This is due to the view angle of the cameras.
As said before, for the object detection part, we have decided to choose a background subtraction since, in our case, it performed well, as the background remains stable, detecting objects even when they stopped moving. Moreover, a threshold was applied to extract relevant areas, and dilation was used to address stitching artifacts that caused players to appear as separate blobs. Finally, blobs were filtered based on the volleyball court area. For object tracking, the particle filter was chosen. Initially, particles have chaotic behavior due to randomness, but over iteration, this randomness decreases, leading to more stable behavior. At each iteration, the previous particle system were associated with the new bounding boxes based on a distance between the centroid of each particle system and the bounding boxes. If no bounding boxes could be associated with a previous particle system, a new system was created. However, due to the limitation of this technique, rapid movements caused delays in adaptation, resulting in temporary inaccuracies. Then, for ball detection and tracking, the YOLO 11 was used to address ball distortion caused by its high velocity. A custom dataset of more or less 1000 images was created using a RoboFlow with bounding boxes manually defined for the ball in each image. For tracking, the same particle system technique was adopted. In this case, the association of a particle system with bounding boxes was not required, simplifying the process while maintaining accuracy. For color-based team identification, the net was used to differentiate team, as players from the two teams never mix. In our case, color-based identification was very difficult due to the similar team colors, and it could be possible if the team colors were more distinct. As illustrated in the figure, the left and center histograms, which are the colors of the two teams, are very similar. Instead, the players with a yellow uniform, the libero, can be easily distinguished. The project successfully developed a volleyball video analysis system using a multiple camera setup. While stitching results showed artifact due to the camera angles, they did not affect accuracy. Background subtraction was effective for object detection but had limitation, especially near the net, leading to occasional errors in team identification. And YOLO significantly improved ball detection and tracking, addressing challenges like rapid movement and distortion. That's it. Thank you for the attention.